Hey robot makers, do you want to know how to use Docker to install ROS 1 and ROS version 2 interoperably? Then keep watching. So the goals of this session today, we're going to be taking a look at how to install ROS 1 and ROS 2 using Docker. We're going to take a look at what Docker is, we're going to look at software containers, some Docker architecture, we're going to be looking at how to install Docker itself, we're going to be looking at what resources containers need, such as volumes and images, and we're also going to be looking at some useful commands as well. So what is Docker? So Docker is software for managing containers. It's an open platform for developing, shipping and running applications. It enables you to separate your applications from your infrastructure so you can quickly deliver software. And with Docker, you can manage infrastructure in the same way you manage your applications. And when they say infrastructure, they mean things like networking and so on. By taking advantage of Docker methodologies for shipping, testing and deploying your code, you can significantly reduce the amount of time between writing code and then running code in production. But for us, it's going to make it really easy to install multiple versions of ROS with different configurations if we wanted to on one machine. So there's a difference between containers and virtual machines. Let's have a quick look at what these are before we move on. So with containers, all the applications run underneath Docker. Docker runs on the host operating system, which in turn runs on the infrastructure. Virtual machines, however, they run on the hypervisor, and each virtual machine needs to have its own guest operating system and then the application loaded into that virtual machine. So each virtual machine has got its own guest operating system, so they take up quite a lot more space. Containers, on the other hand, are a lot thinner, a lot smaller. Containers are an abstraction at the app layer. They package code that are dependent together, so all the libraries and binaries are in the same container. You can have multiple containers that run on the same machine and share OS and kernel with other containers, each running as isolated processes in user space. Containers take up less space than VMs. Typically, it's in megabytes rather than gigabytes, and they can handle a lot more applications and require fewer VMs and operating systems. Virtual machines, however, they're an abstraction of physical hardware, turning a server into many servers. The hypervisor allows virtual machines to run on a single machine, and each virtual machine has a full copy of the operating system. The application, the necessary binaries and libraries, and all that takes tens of gigabytes, so VMs can be very slow to boot up in comparison to containers. So what is a container? So a container is a sandbox process on your machine that's isolated from the processes on the host machine. The isolation leverages kernel namespaces and C groups, features that have been on Linux for a long time. Docker has worked to make these capabilities approachable and very easy to use, and it's really well documented and really it genuinely is easy to use. Architecture, some bits and bobs. So we have client software such as the command line utility. On Mac and Windows you've also got a dashboard which makes it a lot easier to interact, starting, stopping and installing your containers. We have the host itself, so there's a daemon which is just a service that runs on the machine which manages all the containers, manages all the images, all the volumes and so on. And then we have a registry, and that's like a repository that has all the images on there. Now you can have your own registry of things that you've created yourself, or you can use official ones. So we're going to be looking at the official ROS repository as well later on. So installing Docker on Ubuntu is very simple. It's a snap. So from the command line we simply type sudo snap install docker and that's it. It will then install Docker I found it was almost instantaneous to install. It was really quite quick. To install this on other operating systems such as macOS, Windows and Linux, just head over to docs.docker.com/get-docker, and you can see on the screen there we've got Docker Desktop for Mac, Docker Desktop for Windows and Docker for Linux. They don't have the desktop version just yet. When we click on the link for the macOS, we get Mac with Intel chip or Mac with the M1 chip. I'm using the M1 chip on this laptop here. And then for Windows, it's just simply the desktop version for Windows. So if you like these videos, make sure you give it a thumbs up. You comment below, let me know what you think of these videos. Are they the right level for you? Is it what you were looking for? Or is there a subject that you would like me to cover off? And also subscribe to the channel. Click the little bell and you'll get notified whenever a new video goes live. And I typically do a video every single Sunday around 7 o'clock Greenwich Mean Time. And that's a live stream that you can join in as part of the audience and ask questions and interact. And I also do a pre-recorded video midweek, which is usually around Wednesday or Thursday. So container resources, things they need to run. So we have these things called volumes, and really that just gives local storage to each container. It's like its own file system. We have networks, which is how we give an IP address to enable contact with the outside world. And then we have ports to allow traffic between machines. So it's kind of like a firewall. And if you don't specify a port, you'll not be able to actually contact the machine within the container. So volumes, creating and adding volumes to a container. To list volumes, simply type docker volume ls. So ls stands for list in Unix. To create a new volume, simply type docker volume create and then the name of the volume you want to create. To remove a volume, you simply type docker volume rm and then the name of the volume to be removed. So rm is again the standard command in Unix to remove files. So to mount a volume, we simply type docker run -- mount and then source and then equals myvol, target equals and then the path within the container that you want to mount that on. The important thing to note there is that there are no spaces between the parameters after that equals sign after source. If you put a space between myvol, space target, it won't actually work, it won't recognize that. So myvol in this case is the name of the volume and the mount point within the container is /app in this case. Images, so we pull images from a registry. So to pull an image, we can simply type docker pull docker /getting -started and that'll bring down the getting started container. We can then type docker image ls to list all the containers that are currently installed, and to remove an unused image we can type docker image and then prune, and prune will get rid of any unused images but keep those that are currently being used. So some other useful commands as well, some things to keep Docker in check. We can type docker run and then -it, and that's the interactive terminal, and that will mean that it'll bring up a little hash, a little command line, so you're then actually working within that container. You can use docker images rm and then the image name to remove an image. You can do docker container ls -all. So if you do docker container ls, it will list all the currently running containers. If you do docker container ls -all, you'll get all the containers, even those that are not running. If you run docker volume ls, you'll get a list of all the volumes, and if you do docker attach, you can actually connect to a running container. So another option on there is docker -d, and that'll be headless, it'll be disconnected from the terminal. So it'll just fire it off and you'll not see anything on the command line. So if you're in a container and you want to actually stop that container, you type exit. If you want to leave it running but come out of it, so detach, you press Control P and then Control Q, and it will say that it's captured an escape sequence, and then it will exit from that but keep running in the background. So some other commands as well is we have docker ps, and that's a bit like the processes. We can see which of the containers that are currently running on this machine, and we can also do docker run -p and then the name of two ports separated by that colon. So in this case 80:80 will mean we map the host 80 to the containers 80. Any traffic to port 80 will be passed through to the container that's running that. So installing ROS1 in the Docker, let's get to this, shall we? So how to install ROS in Docker, it's very, very easy. We simply type docker run ROS, and what it will do is it will pull down the ROS files without us having to do anything else. It will detect that they're not currently installed as an image, it'll pull the image down, spin up a container for us to run that in. If we want to run version 2, that's fine, we just do docker run ROS. If we want to run version 1, we can run docker run ROS and then colon and then noetic. Noetic is the name of the version 1, the most recent version 1, as at the time of this recording, and we can have as many different versions as we like running in Docker, so we can switch between the two, and we can also do things like bridging the different versions too. So if you want to dive deeper, learn about how to bridge ROS1 to ROS2, you can visit hub.docker.com/_/ROS, and you'll get some more information on how to do exactly that. So I hope you enjoy this short video on how to get ROS version 1 and ROS version 2 running on your machine, and you can do that on a Raspberry Pi, you can do that on a Windows machine or on a Mac. So let me know if you have any problems with this, or if it works just as easily as it should do, and I'll see you in the next video. Bye for now.